This video is for rectangles. So once again, we're going to be looking at the properties of the rectangles and then jumping into the problems to kind of apply them as we're going through. We're going to start by talking about the properties of the sides and angles. Since a rectangle is a parallelogram, we know that opposite sides are parallel. You can see again, opposite sides are parallel. And we also get from a parallelogram that opposite sides are congruent. With a rhombus, we saw that all four sides are the same, but with a rectangle, we do not have that luxury. But opposite sides are congruent here, and we're going to go ahead and apply that in problem 9B, where we know that side length AB should be congruent to side length DC, which gives us the relation 13y minus 22 equals 30. Solving this two-step equation gives us that y is equal to 4. Other properties we know from a rectangle is that opposite angles are once again congruent. But really what the new property is, it's really interesting, is that we have 4 90-degree angles, which is kind of the cornerstone of a rectangle. We know that we have 4 90-degree angles in a rectangle. Now this property is what we're actually going to use to help us solve 9A, because in each of these corners, I actually know that we have 90 degrees. So right off the bat, we know that x is equal to 90 degrees. Additionally, we know that in angle D, this whole angle should be 90 degrees. So the two smaller angles that make up this angle should add to 90 degrees, or this idea of being complementary. So we have the relationship 8x plus 5 plus 61 equals 90 degrees. So we can go ahead and solve this multi-step equation, giving us that x is equal to 3. I really should have probably made this angle Z so that we were not getting a little confused. We'll just make that change right now. Angle Z is equal to 90, and then the value of the variable x is equal to 3. Okay, we can go ahead and actually, I want to figure out what this angle is going to be, just doing some other math as well. We can know that this lower portion of the angle, 90 minus 61, will give us a value. It gives us 29 degrees. We can go ahead and simplify or solve it this way as well. Set up 8x plus 5 equals 29, and still gotten the same answer of x is equal to 3. Either way is completely fine, because we know that the whole angle adds up to 90 degrees, that they are complementary. Now, additionally, we know that this angle C should be equal to 90 degrees. So we see that we have a triangle between the points D, B, and C, which means that we have set up a triangle sum theorem scenario where we will be able to take and add all of these angles together, and they should be equal to 180 degrees, just like we know every triangle interior angle sum theorem is. So solving this would give us that y is equal to 91 degrees. All right. We also have the idea previously that our consecutive angles are supplementary. This also makes complete sense here because we have 90 plus 90 definitely equals 180 degrees, like it should, but even more so that we see that the values are supplementary moving through. Now, on to the diagonal properties. The diagonals are all congruent in a rectangle, so each full diagonal is congruent to the other full diagonal. But what else happens is the diagonals actually bisect each other. The last property is that they bisect each other. So not only are the full diagonals congruent, each half of the diagonal is congruent to the other pieces, which is what we're going to utilize here. That even though this value of 15 is not on the same diagonal as this value of 6x plus 7, we know they are in fact congruent segments. So we can set up the relationship 6x plus 7 is equal to 15. Solving this two-step equation gives us that x is equal to 4/3. I put this one on here specifically. We don't always get nice values. I try when we're creating these problems to give you nice integer values to help us with the solving, but sometimes the answers could be fractions. In this case, the improper fraction 4/3. Don't be alarmed if potentially on future exams or even on the SOL we get a decimal or a fractional value. It is not because we didn't do anything wrong. We are utilizing the properties. It's just that sometimes our answers don't end up being nice integer values. Questions on the rectangle that we had on the test that were issues were in fact this problem involving triangle sum theorem, where we didn't see the triangle in the quadrilateral, didn't see the forest through the trees, and we were stuck. That's definitely a problem that I've seen on SOL reviews. Again, they like to hide triangles inside of quadrilaterals to get you not only to use the properties of quadrilaterals, but also the properties of triangles together. So I will be modeling that as I did on the last test and on your retake. So be mindful of that. And if you have any questions, please ask me in class.